Hi everyone, we are Group 1 from Communication Principles Session 7. I'm Jiaxuan and my group members consist of Jiatong, Weili and Chori. The topics for today is modulation techniques. These techniques will allow us to encode and transmit the signals effectively, whether it's in radio broadcast, a phone call, or internet data. So today, we will focus on three fundamental types of modulation, which is amplitude modulation, frequency modulation, and phase modulation. Without wasting any time, let us proceed.
Hi, my name is Weili and I am here to discuss about amplitude modulation. First of all, let me introduce about the definition of amplitude modulation. Amplitude modulation is a modulation technique where the amplitude of the carrier wave is varied in proportion to the message signal while keeping the carrier frequency constant. Basically, this is how amplitude modulation works. First of all, a high frequency carrier signal is combined with a lower frequency message signal. As a result, the wave has a constant frequency but a changing amplitude to represent the interval. Basically, this is the equations of amplitude modulation. So the highlighted part is the envelope equation and the cos WCP is the carrier signal. And altogether, modulation index, which is M, is equal to EM over EC. From the frequency spectrum, we know that the bandwidth is twice the highest frequency of the modulating signal, which is 2 FM. Secondly, most of the power is concentrated in the carrier and sideband, which leads to the inefficiency of power transmission. Third of all, the carrier signal will be much higher than the message signal because higher frequency can travel for a long distance. Amplitude modulation is popular because for a few reasons. First, it is simple to implement. Second, it can propagate over a long distance, especially at night. Third of all, it requires lesser bandwidth if compared to other methods. However, amplitude modulation have a few limitations, which is it is easily affected to noise and interference. Next, it is low spectral efficiency, which is the power transmission.
Hello guys, my name is Chori, and let's continue with the angular modulation. Angle modulation is a form of analog modulation where the angle of a carrier wave, either its frequency or phase, is varied in proportional to the information signal. Angle modulation can be divided into two main types: frequency modulation (FM) that change the carrier wave frequency, and phase modulation (PM) that alerts the phase of the carrier wave. Both techniques of the modulation can be interpreted using the same formula. Phase angle of the carrier signal equal to the carrier frequency multiplied by times plus carrier phase multiplied by times. So, what is the difference between amplitude modulation and angle modulation? Angle modulation is able to modulate the wave to provide a superior noise immunity compared to amplitude modulation. This is because angle modulation that maintain a constant amplitude is able to enhance their resistance to noise and interference. How does FM works? From the slide show that frequency modulation is a combination of a high frequency carrier signal and a high amplitude modulating signal and provide an output signal that changes in frequency according to the amplitude change. And the variation of frequency modulation is determined by the frequency deviation formula. That is frequency deviation equal to Kf multiplied to Em, whereas the Kf is frequency sensitivity constant and the Em is the amplitude of modulating signal. What is the characteristics of FM? FM require a larger bandwidth than AM. The sideband spread by frequency shift around the carrier signal determine the FM signal bandwidth. The formula for calculating bandwidth is bandwidth equal to 2 times frequency deviation plus modulating frequency. This explains why FM needs more bandwidth than AM. Besides that, FM encodes information by varying frequency, not amplitude, making it resistant to noise and ideal for clear, consistent transmissions in radio and TV. Next, what is the advantages of FM? FM offers superior sound quality, low noise interference, and stability, making it ideal for audio broadcasting in radio and TV. What is the application of frequency modulation? Frequency modulation used in radio broadcasting, TV sounds, transmission, and two-way radio system, like walkie-talkie industry, such as security and transportation. Next, we continue with phase modulation. In phase modulation, the carrier signal phase is altered by the modulating signal encoding information in phase shift. This method is useful in noisy environment for stable communication. So what's the difference between phase modulation and frequency modulation? Phase modulation changes the carrier phase, while frequency modulation alters its frequency. PN is easier to implement but less common on its own.
Next, we will proceed to the radio-digital modulation. Radio-digital modulation actually works similar as analog modulation and frequency modulation, just that the difference is it will encode digital information, which means it will transmit the digital signal in binary data, which is 0 or 1. So there are three main techniques for radio-digital modulation, which are amplitude shift keying ASK, frequency shift keying FSK, and phase shift keying PSK. Firstly, I would like to introduce the amplitude shift keying ASK. So in this technique, it will vary the amplitude to represent the binary data. So you can notice that when our digital signal is high, which is 1, the ASK modulated wave will give us the output of the carrier. Instead, when the digital bit becomes low, which is 0, it will give us 0 value for the ASK modulated wave. Next, we move on to the frequency shift keying FSK. This technique will shift the carrier's frequency between the discrete values for binary encoding. In this technique, you will notice that the logic high 1 will be represented by higher frequency. In contrast, the logic low 0s will be represented by a lower frequency. Next, we will proceed to the PSK, phase shift keying. This technique will change the phase of the carrier wave to represent the binary data. So in this graph, you will notice that when the logic state change, no matter from 0 to 1 or 1 to 0, the phase of the carrier is shifted by 180 degrees. In contrast, if the logic state remains unchanged, the phase of the carrier will also remain unchanged. Radio-digital modulation techniques plays a vital role in modern communication system, as it will offer an efficient, reliable, and high-quality signal transmission. Firstly, the digital modulation is the foundation or backbone for the cellular networks. Secondly, it will help in the satellite communication. Because digital modulation can transmit signals over a far distance, then we have the digital radio broadcasting that relies on radio-digital modulation to provide a high-quality audio and greater channel capacity. And next, we will have the wireless communication such as Wi-Fi and Bluetooth. And for the application in IoT, Internet of Things, and M2M, which is machine-to-machine communication, the advantages of the radio-digital modulation is high data transmission rates. This is essential for the applications such as video streaming, online gaming, and real-time communication, where speed and reliability is very critical. Secondly, unlike analog systems, the radio-digital modulation is robust against noise and interference. This robustness ensures a clear and reliable communication even in a challenging environments such as crowded urban areas.
So now, we will explore the recent advancement in communication fields. In terms of this, the first thing we want to mention is the 6G wireless communication system. The 6G is helped to overcome the constraint from the 5G, such as the lagging of the system. The 6G is very useful to handle the massive of the data if compared with 5G. The second advancement in communication fields is about the IoT communication. In terms of this, narrowband IoT, which has the smaller band than the broadband signal, it leverages efficient modulation for a low-power device. So now, what is the impact and benefits of the communication system to society? In terms of connectivity, it is important to enable the global communication and improve the disaster response and emergency service. In the aspect of education and entertainment, the communication will facilitate remote learning and access to media. Lastly, in terms of healthcare, the digital communication will play an important role in telemedicine and remote patient monitoring. Last but not least, there are some misconceptions from the public about the communication system. Firstly, public believe that the modulated signals such as 5G will cause the severe health risks like cancer. However, the scientific studies show that there are no conclusive evidence linking regulated frequencies to health hazards. Lastly, in terms of legal and cultural, public believe that all modulation-based communication is prone to surveillance and privacy invasion. However, in fact, the legal regulations such as GDPR ensure the responsible use of communication technologies. That's all from our group. Thank you for your attention and goodbye.